I've got another great fan video for you today. We're going to be taking a look at the CoolerMaster Mobius120p ARGB. We're going to be taking a look at the CoolerMaster Master Fan SF120M ARGB. And we're going to be taking a look at the, again, CoolerMaster Master Fan SF120p ARGB. Welcome to Computer Tech and More. And let's jump right into those graphs and see how these fans compare. Time for data. So first up, we have some basic spec information that I was able to get off of CoolerMaster's website. All these fans are made by CoolerMaster, so that was one-stop shop. First up is the Mobius120p, which is based off of the same blade design as the Mobius OC. It is their Mobius series. It is a 26mm fan based on their website, so it's a little bit thicker than an average fan. The Master Fan SF120M is a bog standard 120mm fan, and the SFP, I believe, is a standard fan. I just didn't find it on there. As for bearing type, the Mobius 120p is a hydrodynamic slide bearing. The SF120M is a dual ball bearing, and the SF120P is a rifle bearing. All three are 12 volts. LED 5 volts if I could find it. Power consumption 35 amps, 12 amps, 24 amps. Speed range, the Mobius 120p goes from 0 to 2400. The SF120M has a speed selector, so it has high performance, or it goes from 650 to 2000, or from to 16 or 12. And the SF120p goes from 1000 or 650 to 2400. So we're going to be primarily focusing on the higher performance values. Airflow is rated at 75.2 for the SF120M, 62, 46, 35, and for the SF120P, 43. As for static pressure, the Mobius does 3.63, the SF120M 2.4, 1.63, 0.9, and that's all these are in millimeters of H2O, and the SF120P does 2.32. The noise level listed at volume is 30, 22, 30. Mean time between failure, I could not locate it for the Mobius, but I imagine it's similar to the other fans. The SF120N at 280,000 hours, the SF120P at 160,000 hours. Alrighty, so the first graph is my case simulation testing. So we have airspeed vertical, and we have distance from the fan horizontal. And the distance from the fan are taken at 4 data points. The 4 data points represent different case sizes. So 6 represents a small form factor type case, where pressure optimization tends to be a little bit more important. So you're going to want to pay attention, if you're looking at a form factor build, is the 6-inch mark, as well as performance through my CPU AirCooler. Both those are more pressure-oriented applications. Next, we're going to be taking a look at the 9-inch mark. 9-inch represents a small compact case, but still more or less a standard case design. And the 11-inch mark represents a mid-tower case, something like the Corsair 550D, or something like the Fractozyne Meshify C, Meshify 2, whatever the mid-sized tower case is. And then the 14.5-inch mark represents a big computer case, something along the lines of the Fractozyne Torrent. Next, you can look at this data from one other perspective, and that is how quickly does the air, or how much does the air spread out after it exits the fan. In my opinion, the ideal fan creates a focused funnel of air being pushed out the back, so it doesn't spread out everywhere in every direction. So this way you have a nice strong column of air being pushed from the front of the case to the back of the case. In an ideal world, the fan would lose no air velocity as you traveled from the front to the back. However, we don't live in an ideal world, so we are looking for these lines to be as flat as possible. And bar that, you want them to be as linear as possible. You don't want the fans to be arcing down and losing performance dramatically as time or as you move back in distance. So now that all of that is said, let's take a look at the fan. So first up, we have the Mobius 120p, and its lines actually look fairly flat from 3 meters per second approximately to 1.5. So that is a pretty steep drop off, but it creates a pretty linear effect, but we can't tell exactly how good it is without comparing it to the other fans. We'll get to that in a couple minutes. So we have its key RPMs that I took for this data set, but let's go ahead and jump to the next fan. Next, we're taking a look at the Masterfan SF120M ARGB, and it doesn't look to have the same high end. It still looks fairly linear, but it looks almost a little bit steeper. But again, we can't really tell, but this is the performance data for this particular metric. Next, we have the Masterfan SF120P ARGB, and its drop-off looks very dramatic. I would hands down say I would not recommend the SF120P as a case fan unless you are specifically in a small form factor case or really need something with potentially higher pressure. The P represents pressure. Now, we're taking a look at these fans' noise normalized. So my noise normalized value is based off of the Noctua NF-A12X25 spinning at around 1,200 RPM, and I found that level to be particularly silent on that fan while pushing a good amount of air. So I decided to make that my baseline result. So in these graphs, my control fan is a mashup between the Noctua A12X25 and the A14, where it's like 4 parts A12X25 per 1 part A14, just to get a kind of control fan that was representative of what I considered to be a good fan. So fans that perform underneath that level should be considered not very good performance. Fans that meet or exceed it should be considered good to excellent fans. Now, all of that said, let's I'll want to quickly address my margin of error. So my margin of error in noise normalized noise testing is plus or minus about 3 decibels. It is just the accuracy of my microphone that I have right now. And through supporters like you on my Patreon page, I hope to be able to buy a better microphone for essentially noise testing. So please check out my Patreon page linked below. And or subscribe to my channel. It'll also help it grow and allow me to gain traction and support to get fancier equipment. But that's my margin of error. So fans that are functionally within 0.1 meter per second for airspeed testing, because that's the accuracy of my anemometer, or plus or minus 3 decibels should be considered functionally equivalent. So taking a close look at this data, we can see that the Masterfan SF120P is a pretty poor performer. This is my control fan. This is the Masterfan SF120M. It's doing fairly well, and the Mobius120p is even better. Moving things up to that 100% PWM signal, we can see that the SF120p actually does pretty well at initially and then has a very steep drop off. It just loses performance way too rapidly. I wouldn't recommend it for as a case fan, period, end of story. Let's move on. The Masterfan SF120M follows fairly closely and matching my control fan, though at a little bit lower performance value. So it is almost good. So not fair. It'd be like giving it a B minus, where the control fan would be, I don't know, a B or a B plus, something like that. Let's say the control fan is a B plus. So the Masterfan SF120M would be like a B, and the Mobius120p would be like an A, or maybe even an A plus. It is doing very excellently. Switching gears, we're now taking a look at these fans running through my CPU air cooler, the Noctua NHU12, I think, NHU12A, and the graph on the left side is RPM versus airspeed, and that is an efficiency of the blade design. So that is how efficient are the blades at moving air through that CPU cooler. On the right side is noise versus airspeed. That is how quiet is that fan at producing that airspeed. So I think both are valid ways to look at these at fan performance. So right away we have my control fan in this blue dotted line, and we can see that the master fan SF120P starts off pretty poorly, kind of catches up, and then gains performance on my control fan as we reach higher RPM levels. The master fan SF120M outperforms my control by a little bit, but doesn't have the same top end. It's actually a pretty good result, outperforming it pretty substantially. And the Mobius is just kind of hands down doing better than the other fans. Not significantly more than the SF120M, but by a little bit. Taking a look at things from the other perspective for noise performance, the Mobius just kicks butt. It is the best. I'd give it an A++ even, maybe A+. The Masterfan SF120M definitely is in that A category. It is doing very good. The 120p is following my control, so that's a B+. Now taking a look at RPM versus CFM. So I run my fans through a CFM, or a little tube, to calculate CFM. I know the inner diameter, so I know the airspeed, so I can calculate the volume, cubic feet per minute, of air that travels through that tube. What CFM doesn't give you is, in that testing through the tube, is how wide does it disperse air? How much loss is lost in that performance of fan when it spreads out the air in every direction? That's why I think it's a very good point to do a case simulation test, where it gives the air the opportunity to spread out in every direction and lose performance. Because once you're putting it down a tube, the air tends to all travel in that same direction, and the performance differences matter quite a lot less. So once again, we have RPM versus CFM on the left side and noise versus CFM on the right side. And my control line is the blue, and we see that the SF120M and the Masterfan and the Mobius120p are following my control fan fairly closely, though technically slightly under it. The SF120p is substantially lower in performance. Looking at noise versus CFM, and the Mobius120p is once again kicking it. It is doing very well. The SF120M is still doing very well. And there's the control, and the 120p is doing pretty poorly. CoolerMaster Mobius120p ARGB. CoolerMaster Masterfan SF120M ARGB. CoolerMaster SF120P. Next, we're taking a look at the fans. This is noise normalized performance through my CPU cooler. And in this testing, I ran the fans through my CPU air cooler to get their performance values. At the bottom, you'll notice a number with a W behind it. So in this case, 130, and the W represents watts. So going through my specific air cooler, I made a video about it, but I did a whole series of testing for what given airspeed do I get a wattage on my unlocked CPU. So the only variable here was airspeed. As I dropped airspeed, the CPU would always be at its maximum temperature of 91 degrees C, which is where thermal throttles. So at 0.6 meters per second, the CPU would run at 130 watts. If I ran my CPU or ran my fan and it achieved 2.1 meters per second of airflow, I'd be getting close to that 225 watt limit on my CPU. So how can you use this data? Well, you would use it, unless you have the same CPU cooler as me, you would use it as a baseline. So let's say your CPU cooler came with a Noctua NF-F12. Well, in this noise normalized value of 40 decibels, again, I believe I stated the 40 decibels is representative of my Noctua fan running at 1,100, 1,200 RPM. And I found that to be good airflow while still being very, very, very quiet, actually almost completely inaudible, sitting in my chair with my desktop like next to me on the floor. So that's why there's that 40 decibel base mark. So if your fan had the NF-F12, it would be moving air at 0.7 meters per second. And it's associated with this wattage on my CPU air cooler. But let's say you replace that fan with a Noctua A12X25. Now you're able to, at that same noise level, able to achieve 1.2 meters per second of airflow. This instantly allows your CPU to either run at a higher wattage if it's unlocked, or run quieter because you can now back off that fan speed to run at the same level, or you could run it at that 1.2 meters per second of airflow and have it achieve lower temperatures in a locked CPU. So there are just advantages to having a higher performing fan. Now that all those disclaimers are out of the way, the Mobius120p ARGB was spinning at 2,235 RPM, a truly excellent result, if I do say so, moving 2.1 meters per second of airflow. The Masterfan SF120M ARGB was spinning at 1,774, moving 1.7 meters per second of airflow. Had I not tested the Mobius, I would have said that the Masterfan SF120M is the best fan I've ever tested. But it's just beaten out by the Mobius. As we move down, here is the Masterfan SF120P, moving 1.2 meters per second of airflow. So it is within margin of error, though technically better than the NF-A12X25 in this test. And we have a number of other fans listed below. Moving things along to 100% PWM fan signal, the Wonder Snail and the Tough Fan 12 Turbo achieved the same 2.2 meters per second of airflow. I just wanted to note it because I thought that was a good fan, but I wanted to save space vertically. And they had similar, though different, noise levels. So at the top of the graph, we have our 3,000 RPM fans. They just crush it. So the T30, the NF-F12 3000, and the NF-A14 3000. But you'll notice that they are pretty noisy. The Mobius OC was spinning at 3,200 RPM, but only 49.6 decibels. So basically 50 decibels. That is a good 10 decibels below the T30. But it also doesn't achieve quite the same airflow. It only achieves, I say only, 2.7 meters per second of airflow. That is still an excellent result. It is way up there at the top of the graphs. That fan by itself could almost max out my CPU, which tops out at about 250 watts on my cooler. I just could not get it to draw more than that. So right then and there, and a truly excellent fan just even by itself. Silent 4 Pro spinning at almost 300 RPM less. move 2.6 meters per second of air at functionally similar, but the Mobius technically beats it, 53.4 decibels. The Mobius 120p ARGB was spinning at 2,385 at 41.1 decibels, so that is actually a very good result, moving 2.2 meters per second of air. So it is substantially quieter than the Wonder Snail, making it a good choice. Do note with the Mobius 120p, it is based off of this exact same blade design as the Mobius 120 OC. It's just not spinning quite as fast, but it is still a very excellent result. It is still way up there towards the top of the graphs, and it's got a very good noise value to its name. Moving things down, there's the Wonder Snail, then we have the Masterfan SF120P. It's substantially noisier at 52.1 decibels and moving 2 meters per second of airflow. So it's still a good result. It beats out actually the Noctua A12X25, but it is noisier. Then we have the Masterfan SF120M ARGB spinning at just about 2,000 RPM and 41.6 decibels. So you'll notice that the Mobius 120p and the Masterfan SF120M have functionally the same noise level, despite pretty substantial difference in RPM and substantial difference in airspeed. Mind the Masterfan 120M is still a very good fan, matching the performance level of the NF-A12X25. Next, shifting the data to not shifting it, but taking a look at the data from a different perspective. So we have airspeed versus decibels in the horizontal across all RPM ranges for these fans. We have the Mobius 120p right here. It is a very high-end performer, sitting at the top of the graph. I included the Mobius 120C because I recently tested that alongside these fans, and you can see that the data points line up almost perfectly, which is good. If they didn't line up, it would be very bad for my testing because they share the exact same blade design. The only difference is how fast can the motor spin. Next, this green line is the SF120M, and it is a good result, sitting above average, but it's got some, I'm going to call it odd behavior. And last, but certainly not least, is the SF120P, sitting kind of in the middle of the road. Mind, it isn't a terrible result. The worst fan I tested was the Arctic P12, and it was particularly noisy. The only fan kind of just as noisy was the Noctua F12 IPC 3000 RPM fan. Now we're jumping back to my case simulation test. These are all noise normalized versus airspeed. We have distance on the bottom, airspeed going vertical, and right here at the top, we have in this thicker blue line, the Mobius 120p, and in the green line, we have the OC version, and you can see they share similar performance characteristics, with the 120p technically outperforming it. But this is within variance between fans, as they could have slightly different RPMs, which they actually do. I have the RPMs listed, or slightly other different differentiating characteristics that create minor performance differences. Next, we have the Masterfan SF120M, and it's sitting towards the top of the charts as well. It just can't hold it up at the very end of the data points, with the likes of the Tough Fan 12 and the Wonder Snail just beating it out at the last data point once it reaches basically a very large case. As for the Masterfan SF120P, it is terrible. It drops off significantly very quickly. Mind, it isn't the worst fan I've tested. That belongs to the likes of the Noctua F12 and the Noctua NF-S12B and A. Moving things up to 100% PWM signaling, the 120p is once again still basically a very steep drop off, going towards 0. Once again, wouldn't recommend it as a case fan. Moving things up to the Masterfan SF120M, it is the bottom of the good fans. So it's lost quite a bit of ground here, but if you're running your case fans at 100% PWM signaling, something has gone terribly wrong in your case, and something has overheated terribly. So take all this data with a grain of salt. And last but not least, we have the Mobius120p sitting, well, it's technically in the middle of the road graphs of the charts, but it gains a lot of ground as you move down it, which indicates a pretty focused airflow coming out the back of it. The Mobius120 OC edition is right here. It just wins out because of its faster spinning blades. But notice that as you reach the back, they're functionally equivalent. So overall, a good result for the Mobius, and I would even say for the Masterfan SF120M. Next, we're taking a look at these fans across the whole range of noise levels. So we have decibels on the bottom, and we have air velocity going on the vertical axis. And we're looking at this in my case airflow test at the 6-inch mark. So right away, we can see that the Mobius120p is sitting right here and is doing very well. It is matching up fairly closely to the OC edition, where the OC has some very odd kind of gain in performance there that we see a little bit of, but it's a little bit earlier, but very similar performance overall. Then we have the Masterfan SF120M still towards the top of the graphs. The Masterfan SF120P is sitting right here functionally in the middle. So, but again, this is at the 6-inch mark, so more pressure oriented. Next, we're taking a look at CFM. So this is, I ran my fans through a little tube, took my anemometer, took the airspeed, I know the inner diameter of it, and got the CFM values. So the Mobius OC edition is ranked at the top at 77.7 meters per second, or cubic feet per minute of airflow. The Mobius120p, again noise normalized, achieved 73.4. So that is a pretty dramatic difference, and I'm not sure if that's within margin of error, but it is a pretty dramatic difference. The Masterfan SF120M achieved 59.9 cubic feet per minute of airflow, and the Masterfan SF120P achieved 37.9 cubic feet per minute of airflow. So it is towards the bottom, while the other ones are towards the top. All right, let's move things on to 100% PWM fan signaling. So right here, we can see that that positions have shaken up a little bit. The T30 is now at the top of the graph, and as we move down, here's the Mobius OC edition, spinning at 3,200 RPM, 49, actually almost 50 decibels. The Mobius120p at 2,000, almost 400 RPM, 41.1 decibels. That is a very, 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 very good result. It is just above my noise normalized value, and it's moving 77.9 meters per second of airflow, which outperforms my Noctua A12X25, both noise-wise and in performance, where the Noctua is only producing 74 cubic feet per minute of airflow. The SF120p and SF120M are functionally equivalent in their airflows, but dramatically different in their noise values. So I don't really know how you want to particularly use this data, but it's just the general characteristics that I personally saw when testing these fans in a CFM pipe tube test. Looking at that data from a slightly different perspective, where it's CFM versus decibel readings, so decibels again, CFM, we can see that the two Mobiuses follow a very similar trend line, the OC edition having more curves in it, but a similar trend line. The Masterfan SF120M sitting right here between sort of my more average good fans and the Mobiuses. And then right here at the bottom end of what I would consider the good fans is the Masterfan SF120p. Now that we've finished taking a look at the graphs and the data, let's go on to our open box experience. So this fan's blades, like several other actually CoolerMasters that I've looked at recently, is very reminiscent of the Noctua NF-A12X25. And it's just the general blade shape, the curvature, that sort of general appearance. However, it clearly does not have the same number of blades. So that is 7 versus 9, if I counted it correctly. Anywho, the shape is very similar. However, the blades are thicker, which does tend itself towards pressure type applications. However, in testing, it did well overall in pretty much every aspect. And part of that does come down to this outer ring. So Noctua has gone with the approach of getting the blades as close to the edge as possible. Because an ducted fan, however close you can get the blade tips to the outer wall, is how good it's going to be in pressure type applications and overall efficiency of the fan in that. So by having essentially the outer housing be built right into the fan blades, it means that it's perfectly enclosed. However, there is a gap between the outer ring and the frame. However, I would call that in A, maybe even A+ category. It's very tight against the outer frame, which is very good. It means no air can leak out backwards. Although in these ring designs, it really shouldn't. One downside with this ring is that it does require a larger motor to get the fan spinning at a high RPM, because it just means that there's more weight on the outside of the fan. But CoolerMaster has done a good job of making a high-performance fan despite this extra weight. In terms of the blade thickness, I don't have measuring tools, but I would say they're thicker than the Noctua fans based on feel, but I don't know exactly how much. In terms of the shape, they have a little bit of a cupped shape, but not extreme. They're definitely getting most of the angle by actually just the angle of the blade, as opposed to having it be a swooped, almost spoon or a spoon-like shape, basically. At the top of each of the blades, it's got a little flat area before it leads into this sharp point right there, where it takes in the air. This is how the RGB looks on the Mobius120 ARGB. You'll notice that I have it on a static color right now, and you can see the RGB LED lights in it. Although on camera, it's not quite showing up as well as I was kind of hoping to. There we go. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 of them in total. And it creates a pretty good ring effect around it. However, you do see the bright spots on it. And the back RGB on my RAM sticks and the fan are supposed to be the same color. And this is another example of how RGB lights can be different colors. Letting the fan just do kind of every color of the rainbow, just cycling through it. This is kind of the way it looks. So again, you get to see how it kind of ticks over as each of the LED lights is engaged. So again, 8 of them, it gives a pretty good effect. I'm pretty new to the RGB space, meaning I don't really have that many in my computer. But I would call the effect adequate, but not excellent. At some point, I'm going to just have to do a roundup of a bunch of different RGB fans and kind of talk about what I think of how each of them look visually as compared to how I think they perform as a fan, meaning how they do at their job. But depending on what you want to do with your setup, maybe you care more about the lighting than the cooling, and we'll talk about it that way. But anyways, that's how this one looks. Let's get on to the next part of this review. Before I forget, this is how the fan looks from the back. Pretty run-of-the-mill, not really all that great, but I guess kind of okay. Pull test, I found this fan to be quiet, very quiet, just like the Noctua. I had no issues with it whatsoever. And that's really interesting because the blades are actually pretty close to the edge of the frame. Mind, these rubber feet do give it a little bit of an offset, but hey, that's kind of what I found. So it's just really impressive, and so that I could recommend this fan in a pull configuration if you wanted to use it that way. However, most fans are prettier in push, so you'll have to decide if that's worth it to you to buy this RGB fan to replace, I guess, whatever stock fans came on your cooler to be in a push-pull configuration. Back to the blade shape themselves. They appear to be a very wing-like shape. They don't appear to have much of a cup, or I use cup, spoon type shape, so this curve, so air would come in this side and get accelerated out the back. So it gives you a flat front and then accelerates it down. These appear to basically be more or less, they're not completely smooth, but fairly smooth on the bottom, and just relying on kind of an angled shape down, and then the top has a curvature to it for a similar type effect, more like a wing than, I guess the best example would be the Arctic P12, where it's got a really pronounced cup shape to it. But whatever they did, it's got great performance characteristics. Other features about this, it's got this is not a braided cable, however it is sleeved. Feels pretty good. It's got a little bit of a stress relief on the ends there. And for the RGB one, it is again sleeved but not braided with a secondary connector there. I would definitely like to see this higher up for better daisy chaining. And this doesn't come with those nice short cables to make daisy chaining easy. So you're going to have a whole bunch of wires, extra cables to deal with in your cable management. So that is a big downside of this fan, and actually the Mobius sitting over there. So I do want to do a quick side-by-side of these two fans. So interestingly enough, these two fans both have 7 blades, and they are visually very similar. I mean, the differences that I'm seeing visually across like the shape of the blades and anything like that is pretty much negligible. It's just not coming up to my eyes. So they could have just used the same blade on both these two fans. The back even looks near an identical. The sweep angle, just everything about it looks basically the same, which is both good and bad. It means that they found something that works really well, but then they're just making market sectors for the exact same product, both just different lighting effects, I guess. But that's kind of beside the point. This is the RGB look for the CoolerMaster Masterfan SF120M RGB. The color appearance visually looks relatively close to the purple that is on my RAM sticks, but it's still not exactly the same. This fan has 6 lights in the hub and appears to have 1, maybe 2, 3, 4, 5, 6, 7, 8 in the housing around the outside based on the bright spots that we can see. The bright spots are not as noticeable in person, but looking through a camera, they certainly are more noticeable. And I changed the lighting scope, meaning where the focus of the camera was, and it changed how the bright areas appear. But if we take a look in there, this is how it looks pretty up close. I'm gonna go ahead and switch the mode over to color changing mode, so it basically is unicorn puke crap. And look how smoothly the colors change. Because there are fewer LED lights in it, its transitions are not quite as smooth as other fans, but it gets a very cool looking effect because it has that inner and outer rings. Personally, when I'm shopping for a fan, I care most about its performance and RGB second. So I'm not strongly opinionated on RGB yet because, well, my setup, this is my first build where I actually have a window, and the RAM sticks are the first real component that I bought with RGB specifically. The hub in the middle does not appear to have any color changing capabilities. Let's take a quick look at the back of the fan just to see how it looks. There we go. I turn it around, and the back, well, I'd say it's a little better than like a bone stock average run-of-the-mill RGB fan because of the light ring around that. It gives it a little bit more detail, but other than that, it's very basic looking. As a side note with this fan, if you just want a basic little bit of illumination, you don't even need the RGB header. See, I have it unplugged. And the inner ring just glows by itself and will give a subtle ambiance to this fan. I actually think it's very attractive, but it is a little bit wasteful just to use this fan this way, considering that it has all the other RGB LEDs installed. Now, with all that said, let's move on to the next section of the video. This is the RGB appearance for the CoolerMaster Masterfan SF120P ARGB. So, color matching to my RAM sticks is pretty good visually. The RGB lighting on this fan appears to be outward in. That means the lighting appears to be on the outside and be projected into the fan blades, which are this clear plastic as opposed to an opaque translucent material that is there to diffuse the light through it. So it gives it a very different effect, more like a halo ring than several of the other fans that I've looked at recently. I think it looks really cool. Let's go ahead and turn off the static color that I prefer in my cases. And well, this is what it looks like with it rotating through. And because there are so many LEDs in this, it has a much smoother transition of lights as the colors change going around the wheel. So it's a much smoother transition. So more lights means that you can have more lighting options. So more finesse in that color. So instead of going green to an aqua, so blue-green, straight to blue, you can have a little bit more fine-tuned transition as it kind of moves around, because it's not just a yellow bar. There's actually a transition through that yellow bar. That's what I'm trying to say here. Anyways, let's refocus the camera, and there are the lights right around the edge, and you can see that there's nothing on the inside hub. They're all on the outside housing. All right, let's take a quick look at how it looks from the sides. So I'm going to try not to get the wires cut in the fan blades. So you can see that the diffusion from the outside looks really good. It's not as, how should I say, you can't really see the individual lights as well. So this is actually one of the better setups I've seen. Now from the back, it looks pretty bad in my opinion. The light doesn't diffuse as well in the back direction as it does in the forward direction. So that is a downside of this. You would really want to make this a showcase fan, so it would only go in a forward-facing direction. But if we unplug the ARGB header like that, you can just see that it's just basically a regular-looking fan. Anyways, let's move on to the next section and keep this review going. All right, before we get into the value proposition, the Mobius120p is a $35 fan. The Masterfan SF120M is a $38 fan, and the SF120P is a $35 fan. So value proposition is a given performance per dollar. So fans that are significantly cheaper that still perform well will jump to the top of the graph, while fans that are more expensive and don't perform well drop to the bottom, kind of vice versa, anywhere in between. So where do these fans lie? The Mobius120p in the 9-inch mark in noise normalized testing ranks towards the top, but not in the peak top, but it is towards the top, so it's in a good position. The Masterfan SF120M is sort of more middle of the road. It's still an okay position, while the Masterfan SF120P is in a poor position in this graph. When we're looking at 100% PWM fan signaling, we see that the Mobius120p is kind of bottom-ish, middle of the road, so it's not in a great position overall. Neither are the SF120M or the SF120P. Moving things along to CFM testing, noise normalized, 100% PWM signaling, we can see that the Mobius120p does rank very well. It is towards the top of the graph in a very good position in the value proposition, especially considering that it's an ARGB fan. As for the Masterfan SF120M, it's still in a good spot. Not quite as good as the Mobius, but I would still say it's in a very good position, while the SF120P is more in the middle of the road. Once we take a look at that 100% PWM fan signaling, that position drops. They are all below average, I would say. So take that for what you will. And the last graph to look at with this data is the value proposition through my CPU AirCooler. So the Mobius120p is in a very good position once again in noise normalized testing, ranking towards the top of the graph, while the P is shifted more middle, still actually ranking pretty well, and the SF120M ranks fairly well as well. Once we're looking at that 100% PWM fan signaling, they tend to be towards the bottom once again. They, for some reason, just don't rank that well when looking at the very high end. Mind, it is beating out the Noctuas, tend to do a little bit better at the high end. Actually, the Noctua A12X25 looks to be functionally equivalent to the CoolerMaster Mobius series. So, thank you for watching. Let's go on to the conclusion section. Thank you for watching my video. Please subscribe for more content. I have lots more fan videos, both coming up and that I've already done, so please check them out, where I've looked at a whole bunch of different fans and I'm getting ready to do a big roundup for comparing all the ones I've tested thus far. Anyways, have a great day. Now that we've finished taking a look at everything else in this video, the fan design, the data, the graphs, the value proposition, this is the raw data used to generate those graphs. First up is the Mobius120p ARGB, then we have the Mobius AF120M, and last but not least is the Masterfan SF120P. You are welcome to use this data for your own purposes to generate graphs or whatever you'd like to do. However, if you use it in any publication, I ask that you reference me as the person that generated your data, because I worked long and hard to get this data and generate these graphs and stuff. Anyways, thank you for watching. Have a good one.